Right, second part of the lesson. Let's look at how to actually complete the square. So first of all, let's be clear on what the completed square form is. It's sometimes called the vertex form. The reason it's called the vertex form is when you're talking about graphs and quadratic graphs, we often call that turning point. Remember in the last video, we said in a quadratic graph, you get a turning point, a minimum turning point, or perhaps a maximum turning point. You often call that turning point of a curve the vertex. So that's why this is called vertex form, because you'll see later that it's going to help us find that turning point. Right, so here we've got a three-term quadratic, which we're familiar with. And here you've got the same quadratic, but it's written differently. And I'm going to teach you how to go from the regular three-term quadratic into this completed square form. This completed square form, you'll notice, has got a bracket, squared, and then there's another little bit hanging on the end. Let's look over here. We've got a bracket, squared, and a bit hanging on the end. So that is the completed square form. That's what we're working towards. And we'll see the purpose of it a little bit later in the lesson. So as we saw from the previous slide, our completed square form looks something like x plus something squared, and then there's that other bit hanging on the end. All right, we're now going to learn how to complete the square. I'm going to sing a song. It's going to be very cringy, but it's going to work because it'll stick in your head because it's a bit of an earworm. All right, here we go. First thing we're going to do is write down this bracket squared. First part is going to be x always. So this situation, you always set up first. Here comes the song. Half the coefficient of x minus the square, then the constant. It's not good, is it? But trust me, this is going to help you remember, because these steps seem a bit arbitrary. Like, how are you going to remember them without some kind of a hook? So now I'm going to tidy this up. I have now completed the square because I have got a square bracket, a completed square, and I'm going to just tidy that up. Minus 3 squared plus 8, y is equal to x plus 3 squared minus 1. So to talk you through what I did there, I wrote down the bracket, squared, and started with an x. So that's always going to be the case, right? So you can write that down before you start singing the song. Then start singing the song. I have the coefficient of x, so that's that 6 divided by 2. Watch out, it's positive 6 divided by 2 is positive 3, okay? So keep the signs. Half the coefficient of x minus the square. What I'm doing there is, whatever I've written here, you simply write it down afterwards, squared. And it's always going to be minus, because the song says so, and because I'll expand this out later and show you how it works. You will always minus, and it's whatever this part is, squared. Then you stick the constant on the end. Now, I'm just talking you through a set of rules here to follow. We'll expand this afterwards, and we'll see that it will always work. This here is the completed square form. We are done. We can check by expanding back out again. So x plus 3 squared is x plus 3 times x plus 3 minus 1 is equal to x squared plus 3x is plus 6x. 3 times 3 is 9 minus 1. Y is equal to x squared plus 6x plus 8. These steps will always work. The song works. All right, write it down, sing the song a few times, and have a go at the question on the right. There we go. Now you know how to complete the square. We're going to keep practicing because there's a few little twists and turns here and things to be aware of. And don't worry, in the next part of this lesson, we're going to look at why we're doing this and how we can apply it. Completed square form. Now, this first one is a little bit different because there's no constant here at the end. It's not a 3-term quadratic, it's a 2-term quadratic. Don't worry, just follow the steps. So first thing we do is write down the bracket squared and the x. Now we kick in with the song. Half the coefficient of x. Don't write down 4.5. Stick with fractions. It's going to be easier, and you'll see why in a second. Half the coefficient of x. When you half it, it's always going to be 2 on the bottom. Minus the square. Then the what's the constant? The constant is 0. So We don't actually need that there. All right. Let's get rid of that. Now, you're going to see now why I asked you to leave that as a fraction, not a decimal, because when you're squaring this, it's so easy to square a fraction. Square the top, square the bottom. That's you done. Okay. Have a go at this next one. Oh, look, the constant is back again. Don't forget, it's minus the square, then the constant. So you're going to have a plus a quarter hanging on in the end. Other than that, sing the song. When you're dividing by 2, don't write it as a decimal, write it as over 2. Pause, write up your worked example. If you need to write a little note for yourself here that there is no constant, then please do. So with the fractions here, minus 9/4 plus 1/4 is minus 8/4, which is minus 2. But you could just pop that into your calculator. More examples. The reason we've got more examples is that there's more layers to go through with this. We're not quite done with all the complications yet. It's a 3-term quadratic. We want to complete the square. Now, one thing we haven't mentioned so far is that you can only use the completed square technique when the coefficient of x squared is 1. And here it is not. So I'm going to make a little note of that. Right. So we've said the coefficient of x squared must be 1. It is not 1, so we have a problem. Now, we cannot divide across by 2 here. The reason we can't divide across by 2 is that it is not an equation. It's not equal to 0 on the left-hand side. If I were to divide across by 2 here, I would be introducing a y over 2 on the left. So dividing across by 2 here is not a sensible move. Instead, what we can do is we can factorize out the 2. 2 times what gives 7? 7 over 2. 2 times what gives 3? 3 over 2. Now you can check that in your calculator to be sure, but you can just, once you've done enough of these questions, you'll realize that whatever you factorized out is going to be the bit on the denominator here. Now we're ready to complete the square, but what we're going to do is I'm going to do a big square bracket. I've got a bracket inside a bracket, so we go with a square bracket on the outside, round bracket on the inside. We're ready to go. That 2 is just going to sit out there. We'll come back and talk about it later. Half the coefficient of x. Use your calculator here if you want to. Minus the square. Then the constant. Now we're ready to do a bit of tidying up. Okay, so we left that 2 sitting outside the bracket, but now it's time to deal with it. We can bring it back in. Now, notice inside the bracket, we have 2 terms. There is 1 term, there is another term. We can times the 2 by the first term, and then we can multiply it by the second term. Don't worry about expanding out that bracket. We actually want to keep it in this completed square form. If you expand it out, you'll be going back up again to where you started. Now, don't forget the 2 is also multiplied by the second part of the fraction. Don't be afraid to use your calculator to do these. Forgetting to expand the 2 back into the bracket and see how it affects the second term inside that square bracket. That's a common enough mistake that people make. Okay, in the next question, the coefficient of x squared is not 1. It's minus 1. But still, we can't do the completed square form unless we factorize it out. So I'm going to start you off here with this. Factorize out the minus. And inside the bracket, it's going to be x squared minus x plus 2. Close the square bracket. Now crack on with completing the square. Right, did you remember to bring the minus back inside and have it affect the second term in the bracket? Okay, so now we're able to complete the square. We're going to see what the point of all of this actually is now in the next part.